To find the inverse of a 2x2 matrix, you first need the determinant of the matrix using AD minus BC. And once you get determinant, you put it over 1 over the matrix, but in the matrix you reorganize it by switching D with A and making B and C negatives. Then you do scalar multiplication to the matrix with 1 over AB minus BC, so 1 over determinant. So after that, you get the inverse here. And then to check your work, you would multiply the inverse by the original problem, and you should get an identity matrix. You work as a disc jockey at your college radio station. You are supposed to play 32 songs within 2 hours. You are to choose the songs from the latest rock, dance, and pop songs. You want to play twice as many rock songs as pop songs and 4 more pop songs and dance songs. How many of each type of song will you play? You first want to find what you need in the word problem, and we find out we need to find how many rock, dance, and pop songs are going to be played. We know that we need 32 songs total, and we need to play twice as many rock songs as pop songs and 4 more pop songs and dance songs. So let's just set it up as x equals rock, y equals dance, z equals pop. So we have x plus y plus z equals 32, because we need 32 total. And we have 2z equals x, because we need to play twice as many rock songs as pop songs. And we have y plus 4 equals z, because we need 4 more pop songs and dance songs. Now we reorder these columns, these rows, because it's easier to solve it. So we change it to x minus 2z equals 0, y minus z equals negative 4. Now we make an augmented matrix from those. So we get this 1, 1, 1, 32, 1, 0, negative 2, 0, 0, 1, negative 1, negative 4. We switch rows 2 and row 3 to make it easier. Then we use elementary row operations to make it into row echelon form. So we do negative row 1 plus row 3. So we get that. Then we do negative 1/4 row 3. And once we get our row echelon form, we can use Gaussian elimination with back substitution to get what we need. So since we know z equals 9, we plug into for z to find for the y. So the y minus 9 equals 4. We add 9, so we have y equals 5. And then to find x, we plug in both numbers. So 5 and 9 into y and z. So we get 32 minus 14 and x equals 18. So we are trying to find a determinant of a 3x3 matrix using cofactors. So you first have to decide which row and column you want to use. And usually you want to use the row of the smallest numbers. So 2, 1, 3. So it just makes it easier. So since we chose this row, we use the first number, right? And that means this column and this row just doesn't get used anymore. So you're forced to use this number. And we have to multiply by the cofactor, which is negative 1 to the power, that is the row plus column. So this is row 1, column 1. That's 1 plus 1, so it's 2. And then we get the minor, which is these 4 numbers here. And then we find a determinant of that, and we multiply it by the cofactor and the first number in the row. Now we repeat that for all of them. So the 1, it's row 1, column 2, so that's 3. And then 3, row 1, column 3 times 2, so it's to the 4th power. Do the minor from this, because this is gone, and you're left with that. Now, once you multiply it, so it goes from here, AD minus BC. So 2 times negative 12 plus 2 minus 1, 25 minus 5 times 25 minus 5, and we added 3 times 8 minus 10, so we get negative 20 minus 19 minus 6, and determinant is negative 45. For Cramer's rule, you first want to find the determinant of a 3 by 3. So you want to make this into an augmented matrix first. And you find the determinant of this, and you want to, for Cramer's rule, you want to switch this column with what you want to solve for. So if you want to solve for y, you replace it with the middle. If you want to solve for the x, you replace it with the first one. If you want to solve for z, you replace it with the last one. So basically, you put the determinant on the bottom, and you put whatever one you switch with on top. So to solve for this, you just find a determinant. Get that, you get the minor, you multiply it and add it all together, and you get 33. And 33 is going to go on the bottom, since that is a determinant of the original matrix. It's going to be what you want over the determinant of the other matrix. Then you decide to use the same thing, the minor times whatever row you used, the first one, then the second one, the 102, 3, 1, then the third one. You multiply it out, then you add it all together, and you get 99. 99 over 33 equals 3.